All right, my demo is vector spaces for people. But forget about the vectors. Let's talk about spaces, people. Specifically, my space. I want to talk about my space. I have a personal space. I like to keep things at a distance, but things can be near me. Left, right, up, down. These directions always move with me, and everything extends from my origin, but this isn't just about me. There's other things in the world. Look at this bird. That bird is above me. Like 10 meters up from my space. Look at that person. That's you. You're like 1 meter to my right. But you see, I'm not so special. We all have our own spaces. Let's talk about bird space. That's right. Bird space. I'm 10 meters down from bird. That's the same as saying negative 10 up in bird space. You're like 1 right, negative 10 up. That's 1 right, negative 10 up. Listen, we're all objects. We have our own object spaces. Hey, look, I have a camera. That has a camera space. You also have your own space. But let's get real and talk about the world. The world space. There's the center of the world, right there. AKA world origin. I'm 1 up in world space. That bird is 11 up in world space. You're 1 right and 1 up in world space. Now let's do some vector math. I'm 1 up in world space. That bird is 10 up in my space. You're 1 right, negative 10 up in bird space. We just did vector math. Wow, people. Wow. We just positioned every object in the world relative to each other. I can get your world position just by adding relative vectors. Just add the rights together, add the left up, add the ups together. That's all vector addition is. Add the rights together, add the ups together. No way, what the heck, people? It took me 2 years of algebra, geometry, trig, and calculus before anyone taught me the relativity of vector addition. We did it in 2 minutes. Yes. More like 3 minutes, sorry. Sometimes things move with me, like my camera. If my camera is always 1 unit to the right of me, then I can just always add my world position with the right camera offset and get the camera position. No matter where I move, see, still 1 right of me. You can call my space the parent of the camera space. It's attached to me. Whoa. Whoa. We just did relative positioning. Let's talk about subtraction. If I take your world position, 1 right, 1 up, and subtract it with my world position, 1 up, I end up with 1 unit right. Wait a motherfucking second. 1 unit right? That's the same as your world position in my space. What? We were just in world space. How did that end up in my space? Listen, I can change spaces just by subtracting. I converted spaces. I can convert world position to my space just by subtracting my world position. You heard right. We just learned spatial relativity, vector addition, and vector subtraction in a few minutes. Whoa, can we do more? Do we have enough time? Let's keep going. Right here, I'm going to read the Wikipedia page on vector.products. Just kidding. This winter, I'm taking a road trip from LA, and I'm going to head to San Francisco in that direction. Well, I might get lost in this blue direction. Is there some way I can know if I'm heading on the right path? Time for the dot product. Dot product. If I multiply the right values and multiply the up values, then add those together, I get the dot product. What, was that too fast? It's okay, ignore that for now. How is the dot product useful to me? If the dot product is negative, it means the directions are facing away from each other. If the product is 0, then the vectors are perpendicular. If the dot product is positive, it means our directions are close to each other. Larger dot product means closer the directions. That's all you gotta know. But we can go deeper. 3D. We can do everything we just did in 3D. Just by including a third direction. Forward, maybe you heard of. I know a secret trick to get my forward direction from my up and right directions. You can all do this with me if you want. If I take my right hand and point it up in the up direction, this might get a little twist, like Twister. Then I curl my hand around towards the right direction, my right. Then the direction that my thumb faces is now the forward direction. That's the cross product. This trick makes the cross product. Cross product. The cross product is always perpendicular to the two vectors. It's also called the normal or norm. Weird. So let's sum this up. We just learned how to add vectors together. We learned about the parent-child relationship, where the child follows the parent. We learned that subtracting vectors can change space. We learned the larger the dot product, the closer the vectors. We learned how to make a perpendicular cross product using the right-hand rule trick. I didn't even study vectors until 3D calculus and physics, after all those books. You just got knowledge bombed. Like Glitch City Demo Night. That's nuts. That's crazy. No, that's just vector spaces, people.